Okay, folks, it's 2:40. I think it's time to start this talk because we have a lot to cover and I don't want to waste too much time on that. So without further ado, this is the talk about Java migrating to 11 in real application, or upper version, of course. Who am I? My name is Piotr Przybył. I'm self-employed as remote freelance software gardener. If you don't know who software gardener is a person who takes care of a software as if it was a garden, meaning taking some weeds out, getting rid of bugs, planting new plants, new features, sometimes doing greenfield and so on and so on. You can send your hate here, or feedback, if you will. What's important is that I'm doing Java for 15 years. Not only Java, I would say I would do 80% of my professional activity is Java developer. Also do some Scala and Groovy. I'm mainly backend and like almost 100% Linux and Unix. And I'm so deeply involved in Scala that it's, as you can see, it's even chasing me when I'm on holiday. I already know who you are because we did a little voting just before. So agenda for today. We'll cover crucial non-technical changes. We'll talk about remove and deprecated stuff. And finally, how to run your application you currently have on Java 11. What we are not going to cover is all this new fancy stuff like new RPs, var or tools and everything. So if you came for Java goodies, this is not going to happen during this talk. Let's do one more voting. Who's running Java post 8 already? Okay, who's running Java 8? Yeah, so this talk is for you. Okay. Okay, Oracle JDK versus OpenJDK. This has been known for years that if you need to install Java, you go to Sun Microsystems page or Oracle page, whatever it is, like javaoracle.com or whatever, and you grab Oracle JDK, you install it, and you run it, and you're fine to go. But there's also a thing called OpenJDK. Who knows OpenJDK? Who's using OpenJDK? Okay, I would say not even a half. Okay, so both are maintained by Oracle Corporation. All right? And in functional aspect, at functional level, they are equal. Almost 100%, I would say. There are some cases, some corner cases when I've heard they are not working equally, although I didn't catch such a case on my own so far. So technically, they're equal. I mean, if you compile your Java program using Oracle JDK, you can run it safely using OpenJDK and vice versa. There's not such an issue. However, there's one key difference between them. This one is open source, and this one isn't free. Okay, meaning you need to pay for it to run it in production. Who has ever read the license for Sun or Oracle's Java? Okay, nobody. Nobody, okay. It also was paid before that. I mean, before Java 8, there were some situations in which we had to pay for running Java programs or for running JVM. We just didn't read that, so we didn't know that. But now we have to pay in production for Oracle JDK per each CPU core or CPU or something like this. And we don't have to pay for OpenJDK. There's a new release schema. So new major release of Java is released 6 months, every 6 months, pretty much like Ubuntu. So they are not waiting for features anymore. We are not observing the situation like, OK, we want to ship something extra with Java, so let's wait a tiny little bit. This is not going to happen. This is not happening. So if it meets the timeline, it's shipped. If it doesn't, it has to wait for next releases, like raw strings in Java 12. They didn't reach this version, which is like really bad news for me. Oracle releases JDK as long-term support version every 3 years. That's why Java 11 is long-term support for Oracle's JDK. And for OpenJDK, from Oracle's point of view, there's an instant lack of support when a new major version of Java is released. Meaning, when when Oracle released OpenJDK 12, or Java 12 was released, they instantly stopped supporting OpenJDK in version 11. meaning you had to switch to 12 or use an outdated, insecure or potentially insecure software. And I borrowed this slide from Azure, from Simon Ritter. So as you can see, we are like more or less here. And for Java 8, this is public support, this is commercial support, and this is extended commercial support. So for Java 8, we don't have any more public support from Oracle. And these are the steps I was referring in a previous slide, meaning that for OpenJDK, you have this no public updates called support cliff. Like when the new version of Java is released, like when they release Java 13, Java 12 is not going to be supported as OpenJDK by Oracle. Okay, and to get this long-term support, you need to pay to get this extended support or this commercial support from Oracle. All right, so this gray or gray boxes are free. These are paid. But we need to remember that there are also other vendors and other JVMs. There's Red Hat, there's Azure, there's IBM, Google, Amazon, Pivotal, other companies maybe as well. And also there's kind of a consortium called Adopt OpenJDK, meaning that when OpenJDK reaches this support cliff, it's not abandoned. I mean, it's kind of captured by them, so they maintain it. They add security backports and so on and so on. So de facto, this gets extended. All right. And now you can repeat after me, because there are lots of these people, you know, they believe that the Earth is flat. They tell you that you should be wearing a tinfoil hat, just to be protected from cosmic radiation, you know, high gain antenna, low gain antenna. And they keep telling that Java 11 is paid. This is rubbish. Okay, I believe people who say that Java 11 is paid, or they, you know, take part in these discussions in forums, they are wearing tinfoil hats, because this is the level of this discussion. Java 11, my friends, is not paid, so you can repeat it after me. Java 11 is not paid. Louder. Java 11 is not paid. Once more, louder. Java 11 is not paid. Remember that, and stop wearing tinfoil hats. Java is still free. You can refer to this link if you're interested. Why is it so? So you can get Adopt OpenJDK. You can install it using Docker, various operating systems, or Windows, if you will. No problem with that. So do you recognize this slogan? Write once, run everywhere. Yeah. So when I started working with Java, it was Java 1.3 15 years ago, and then I even backported some code to Java 1.2. This was the famous slogan from Sun: write once, run everywhere. In practice, it worked like this: write once, debug everywhere. This was the reality. Okay, we know that. So Oracle claims that with introduction of Java 9 and so forth, normal Java Standard Edition applications should just work. However, there are these two caveats: normal, so what's normal, what's not, and should. And beside that, there's this third go, just Standard Edition. Okay, so if you have anything like from this Java EE or Java Jakarta EE, it might not work, just like that. In all other cases, the migration might not be a simple single step. And this talk is about this. So how to convince the business? Let's be realistic for a moment. If you'd like to do something, you need to get the budget, you need to get the time, the manpower, and so on. So before you start actually migrating, you need to convince someone to give the money and the time for that, right? So in my opinion, there are at least a few valid arguments or benefits from migrating to Java 11. I use them, they work, here they are. First, Java Flight Recorder, Java Mission Control. So with really little overhead, just 1 or 2% in production, you can record what's happening under the hood. Java Flight Recorder has been known for previous versions of Java as well, but due to this release schema and so on, Oracle decided to open source it, meaning now you can use JFR for free with OpenJDK, for instance. String has byte. I mean, they are no longer there's no longer character array in strings, but byte array in strings, plus one integer flag to indicate whether these bytes are using or which version of UTF should be used, or better said, because this was the problem that many of our applications are running in English or Western languages, and we can represent each character as a single byte, right? So there's no point in wasting 2 bytes per each character, okay? Even if your name is Stepan, it will work. Unless you're named Pavel, then for the last character, for L, we need to use 2 bytes for this character. Therefore, the whole string has, for Pavel, we have 5 characters, meaning 10 bytes. And for Piotr, we have 5 characters, but 5 bytes, because we don't have any non-English characters. I mean, simply speaking. There's application class data sharing. So if you're worried about your boot up time or startup time, you can increase it greatly. I think with Java 12, it's even enabled by default, meaning that when you start your application and JVM has to read all these jars and build this, where each class is, how it was loaded, security managers, and so on, this whole structure has to be built every time you start Java. Now with application class data sharing, you can just dump it, and then it can be reused using the next time you start your application, provided you don't change your class path. So it's faster, it's simpler to use. And there's also better integration with containers. As David said a few sessions ago, Java is now more aware of the constraints of Docker and other containers as well. And other big changes, in my opinion, are Java unified logging. Finally, there's a unified way to log the internals, what's happening in Java or in Java virtual machine, what's happening under the hood when you're running it. Of course, Java Platform Module System / Jigsaw, JShell. Finally, Java has a REPL. There's introduction of var, which I remind you is not a keyword, because you can have like var equals Tommy, which means var is not a keyword. And finally, we can write scripts in Java. I hope we'll have time to show you that. And finally, Java is removing stuff, or they are removing stuff from Java. And I think this is cool, because finally, like many other technologies or languages like Perl, Python, C# or .NET or whoever, they are just creating new versions which are not backward compatible, which was kind of a burden, in my opinion, for evolution of Java as a platform, as a language, as a whole. So now they are finally decided that, okay, we stopped this deprecating only, now we are removing this stuff. So let's talk about this removed stuff. They coupled this is name of a module, right? Java Standard Edition, Enterprise Edition. So who's using SOAP or XML? Still many folks, like web services and the kind, right? Okay, so you will need to take care of this. I'll show you how, because this was a part of the JVM, now it's not. It got decoupled, these libraries, these tools. Who's using Corba? I was also using Corba, now I can't, because it got removed from Java. It's not even decoupled as far as I know, it got removed. Sorry for you. JavaFX got also decoupled. Applets, decoupled, and applets are gone. Applets are no more. Sad news for you browser fans. And there's also no Java Web Start, and many XX parameters were removed. There were about 800 in Java 8, and now there is slightly more than 500 as far as I know in Java 11 or 12. So they, of course, added a few, but they also removed a vast number of unneeded parameters. Who's using Sun, Misc, and Safe and its methods? Okay, one guy. You're brave. You get the jellies. Okay, you get jellies. Okay, who's using Spring? Keep your hands raised. Who's using Hibernate? Okay, you guys are using Sun, Misc, and Safe too. Only you are not aware of this. So might be that your application will not simply run when you try to start it or run it on JVM 11. There's much more, of course. The whole lists are here, so you're like welcome to check them. What exactly got removed, and there's also deprecated stuff. A thing called enhanced deprecation has been introduced. And what does it mean in practice? There's a new annotation with the capital or big D, and it has an optional parameter for removal, and it can be set as a true. Which means, if you have a piece of code annotated just like this, it will get removed in the next major release of Java. It will be gone. There will be no more this code. It will be deleted, okay? So this is like a difference from the small d deprecated, because we didn't know. Deprecated meant like, oh, you should better not use it, or will they remove it? We weren't sure. It was kind of a Schrödinger annotation, right? Now we know it's going to be removed, deprecated, and deleted. You can, if you can't compile the code because you don't have the code, you only have binaries like jars, you can use scan tool to find out if any deprecated API calls are going to be removed from Java next release. Concurrent mark sweep got deprecated, nashorn got deprecated, and in my opinion, this is just my reading, it's not an official statement from Oracle or anyone else, depreflection got also deprecated, meaning that you are, constructing the name of the class or just grabbing an object and then you are calling this set accessible true, right? So when you need set accessible true, de facto you're doing so-called deep reflection. So this is also in my reading deprecated, and we should be, or we are discouraged to do so by introduction of the module system. Yeah, modules. Modules are everywhere, as some say. Of course, they are in JDK, in JVM, and so on. But are they so popular in libraries and applications? As Kai Horstman wrote in his book, modules are kind of a social experiment. We don't know if they're going to become popular in libraries, in our applications. Sure, the JDK is modular, and there's no way back from that, as far as I can tell. But will our apps and libs become popular? We'll see. Why they introduced modules in the first place? Because of the jar hell. Because if you had the long class path and you swap the two jars having the same class, then you had this conflict like method not found, or somebody installed this jar in Tomcat or JBoss or Wi-Fi or whatever. Then you had this in one environment and you didn't in the other. This was the jar hell, like DDL hell or whatever other hell. And there's also better encapsulation, meaning that they are trying to get us away from this deep reflection. And this is, again, just my reading. It's about moving from class path to module path, which is easier to maintain once you have proper modules and you like to run JLink and stuff. So now you can repeat after me for the second time, because many people say that in Java 11, to run an application, you need to have modules in your code, because Java is modular, because Jigsaw was introduced in Java 9, and like that, blah, 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 yada, yada, rubbish. So you can repeat after me. In Java 11, you don't need to have modules and module path. If you wish, it's not obligatory. But JDK is modular. There's no more this rt.jar file, okay? They are just modules. So migration steps. The first migration step, optional, but I recommend it, is installing SDK man, just to jiggle the versions of JVMs and JDKs you have installed. Then you should upgrade your IDE. Then you should upgrade your build tools and continuous integration, like Jenkins, Hudson, TeamCity, whatever you're using. Then if you have any containers like Tomcat, for example, or Wildfire, whatever we have these days, you should upgrade them as well, because like Tomcat 9 supports, like every version of Tomcat 9 supports Java 9 and above, and from Tomcat 7 and 8 you need to choose carefully the version you're using. I know it's like many people say, okay, we should just go with Tomcat 9, it shouldn't be a problem. I know where you guys are working, because I work in such environments sometimes as well, meaning that we can't upgrade any piece of stuff we would like because it works, right? So don't touch it. So sometimes migrating to 2 versions above might not be possible, but migrating minor version with just barely, but it does support Java 9 and above, might be enough. So you should upgrade, and we should upgrade these containers. And of course, we should upgrade all the dependencies. They are not always in POMs, sometimes in Gradle and SBT or stuff, but we should upgrade them. And then we should try, while we compile it still as a target version 8, we should try running it as a version on JVM, maybe 9, maybe 10, it depends, but always as a version 11. I mean, this is the target version, okay, and the source version, and we try running it using 11. Sometimes when you have these SOAP stories, web service stories, it might be worth running 9 and 10. And for this decoupled stuff like Java SE, we should add explicit dependencies. And this is a very important step. This test and automate, really do it like crazy. In each step, like if you're going to go like Java 9, 10, and 11 and stuff, automate this stuff. Why? Because of this, instant loss of support, for example, or this will ease further migrations, because from now on, Java is removing stuff. So if you don't want to repeat this testing again and again with each upgrade, like 11, 12, 13 in September this year, you should have this automated, right? Not just manual tests. This will be a huge benefit in the future. Extra migration steps are like this. We may try to compile it as 11 and try running as 8 to see if it works. Because sometimes when you own everything, you own the code, you own the platform, because you're running as a SaaS or whatever, then you're safe. I mean, you can do whatever. But I can't do the same thing because we are also releasing our product in good old days. I mean, we have to compile and create this single uberjar file, which can be downloaded by people and has to be runnable for Java 8 and 11. And in case you are in this situation, you'd like to do this step as well, to make sure that even if you compile with Java 11, it will still keep running using Java 8. Of course, you will play with this illegal access, like debug, deny, we'll get to that. Who has seen this illegal access detected warning already? Not so many people experimenting with Java 11. Pity. And to get rid of these warnings, of course, there's this add exports, opens, and reads various flags to the compiler and JVM. Two things might happen. Of course, many more might happen, but these are the most important ones, I think. Missing class and illegal access. This can be missing something, class, method, whatever. If you have missing applet or corba, then I'm really sorry for you, but no way to upgrade, I think. If you are missing anything from JavaX, well, I'm not sure if it's still going to be kept as JavaX, because of this Java EE/Jakarta EE story we had a few months ago. But anyway, if you have, still in Java code, JavaX something from this package, like class or whatever, there is this brilliant post from Nikolai Padlog explaining what dependencies you should add to your Maven or Gradle to make it run, pass the build and run in the production again. If you have missing classes and methods, the compiler complains that, whoops, look, sorry, there is not such class, or you get class not found or method not found exceptions, it means that most probably you haven't upgraded your dependencies, because trying to run an application still using Hibernate 4 using Java 11 might not be the best idea, shortly speaking. If your DevOps teams or administrators or even you see that Java is complaining about some missing XX parameters, you just need to get list of this removed stuff to see how to replace them if they're still used or not, and how to upgrade your scripts. Illegal access. So you have seen this illegal access. Yeah, so even if you're not using modules, you don't have this module path argument. When you compile the code or when you run Java, you will still see or might see these illegal access warnings. It's because our applications, our libraries might not be modular, even not automatic modules, but still JVM under the hood is already modular. Okay? De facto, all of the code, even if you're still using just the class path, everything you have in a class path becomes a huge implicit module called all unnamed. So you have all the modules from Java and just one huge pile of something module of your code. Okay, so there's also what you have in class path is always a module. It's called all unnamed, and if it gets an illegal access, trying to reflect something or read a private methods and stuff, it will get this illegal access warning. And this is the default one. It's called illegal access permit. And I think it's like your friend's option, because when you do something bad, your friend will just tell you, okay, I think you shouldn't be doing this. Right? So it will complain just once saying your application has an illegal access somewhere in the code. This is a friend option. Then you can have this wife approach. Every time you do something bad, Java will tell you that. You're having illegal access, you're having an illegal access, you're having an illegal access. Every time you do this in your code or your code does it, then you'll see a warning. Then you can go the mother-in-law option. Not only it will tell you every time you do or perform an illegal access, it will also show you exactly where it happened because of the stack trace, okay? And finally, you have this father-in-law option, I call it. Deny. Means you can perform an illegal access, but only once. It will show you where, and then you're dead. And the worst thing about this is just there's a kind of a threat or a promise or whatever we call it from the creators and maintainers of Java, broadly speaking, that one day this will be the default one. Not the permit, not the friendly option, but one day if we don't add this all reads, add reads, opens, and so on, if we don't migrate to this fine, shining, and so on modules, we will get this illegal access deny, and our code will no longer work unless we configure it to do so. Yeah, and to configure it, I mean, to get rid, even if we don't have these modules, as I told you in our code, if we don't have module-info.java files in our jars, compiled into module.info.class files, then we can have this add exports, opens, modules, reads, and patch modules options. Then we tell Java that, okay, our all unnamed module, meaning the class path, can access like instant private fields of JVM class, and so on and so forth. So this is the way to like pimp it, because as I told you, all class path jars end up in all unnamed module. Okay, so when you do Java -- list modules, maybe we can do that. Why not? Let's see if we can. Yeah, let's see. See Java, but this is Java 8. So here, just check version. Yeah, it's 11. It's outdated, by the way, but we'll do for the demo. So Java list modules, if I remember. Yeah, so these are the modules. You see, this is the list of the modules, and your module would be just this all unnamed. And imagine there's this. This is one of these thoughts experiments. Imagine this huge module graph. So the modules are, having dependencies on each other, and also your module has dependencies on all the others. And if there's this illegal dependency, illegal access, Java complains about that, right? So to get rid of these complaints, we need to use these options during the compile for Java-C and for Java. This opens this package from this module to another module using reflection. I mean, this is for deep reflection. This is, I'm skipping the slides because I have some code to show you. So I think it's better to focus on the code than on the slides. So there's also add exports. Again, so from a module, we have a package which will be exported to another reading module. And then we might need to add some modules. This might be also a nice option to use even for Java 9 and 10. I mean, you don't, if you have this enterprise edition code, like this JAX-B or activation or whatever, you might not want to jump to Java 11 right away. You might want to go with Java 10 or 9 and just add these modules explicitly, because they are still present there in Java 9 and 10. However, they are disabled by default. So this is the way to enable them, as written in here. Yeah. And add reads, so a module can read, so some targets can read a module, and patch modules, because one of the benefits or effects or whatever we call it, one of the properties of the module system is that using it, we know exactly which class belongs to. I mean, there is no option to have classes from a single package to spread among 2 or more jars anymore. This was the jar hell. With, if you have module path and you use Jigsaw properly, then each package needs to belong to exactly 1 jar. You can't have 2 jars with the same package. So if you happen to need some monkey patching or something, then this is the option, like patch modules. So then we tell Java or compiler, okay, so I know that this module consists of 2 or more jars. Okay, don't worry about this. This is why we use patch module. Okay, and you know, if you have like add reads, add opens, easily the list can get like 2 or 3 screens. It's not unusual. It might happen. So how do you do that? Do we keep this long list of these parameters? It's not needed, of course. We can just add them to option files and just use them as parameters, just like this. Option file 1, option file 2, and so on. It can be Java or Java-C. For example, this might be for one library, this might be for another library, or one product, and depending libraries, whatever schema you choose. One thing, they can't be nested. I mean, they need to be flat files, just like the options in the previous slides. Important thing when it comes to migrating is that your millage of each and every one of you might vary. Okay, so I migrated 2 applications to Java 11 after convincing the business, and we had such and such issues and such classes missing and so on and so forth. But for your products, your systems, your applications, this will be different, of course. However, the schema is more or less the same, I think, especially for backend. If you'd like to see a trivial migration, the code is on GitHub, so we can clone it, fork it, or whatever. Let's run it here. All right. So this is just an artificial application. I wasn't able to show you a real one, NDA and the stuff. So I kind of distilled what happened and created this simple demo. This simple demo, just like the most of our application, doesn't do anything serious. It just exists. So we have just some pojos, Alice, Bob, and John. They are family, as you can see, and then we are creating XML out of them, and we might be sending this XML to an external system or using SOAP or whatever. Then we can use base64, for example, and this is just this application. I mean, nothing fancy. However, when we try to compile it and run it. Is this window? Nope, this I think. Oh yeah, this is, by the way, how and why I recommend, using SDK Manager. You see, or maybe I use the mouse. Just here, this is my alias for checkout, so don't worry, I'm just checking out the tag Java 8. And this is the easy way to switch or swap the version of Java you're using in this very shell using SDK Manager. And then I'm just running Gradle clear and run, so let's run this application. This is a message from SDK Manager, and as you can see, the compiler warned us that we are using some internal proprietary API and may be removed in future release. And in fact, it got removed, but we got this warning. Let's say we disable the warnings because we can, and we don't see any warnings in our Jenkins or whatever. And then this is the output, meet John. As you can see, this is just this string method, and here we have this XML, and here we have encrypted base64 name of John, and the actual character array inside this string is JOHN. We can see it here. See, this is this, where was this? Deep reflection, deep look into. So we have this deep look into string. You guys see the code, right? Okay, it's okay. So I'm just opening the declared field called value of the string class. I make this field accessible. As you can see, this is the dip reflection. This is the daemon. You shouldn't be doing this. And then we get this value field from this input, and we can print, and after casting, of course, here we can print it. As you can see, here's the character array. All right? So we are using for John, we are using we have 4 characters, meaning 8 bytes. Okay. Now, if we switch to Java 9 and Java 9, another comment, and you can see here how easily I can switch to another Java version, like in here. See? Just SDK use. If it's not installed, SDK man will download it for you and enable Java 9 in this terminal window. See, Java version. Now it's 9. It's so easy. The output looks more or less the same, except we don't have this warning here. And now we have bytes in this string, not characters. So this is, in my opinion, one of the arguments to convince the business. If you happen to process a lot of strings, and many of our applications just do that, they're transferring strings into strings, you can convince the business that the application will use half of the memory for your strings, if you're using, of course, Western characters. So let's take a look into the code. Let's take a look into the code. Here I had to use another method because that previous one was removed. So I had to update the code here. And see, here is a casting to byte array, not character array, because they changed the implementation of string. And to make this work, I had to pimp up the Gradle's build a little bit. So for compile Java, I had to add this Java XML bind. See this add modules. If I don't do that, let's pretend I don't do that. So let's do that. Just Gradle clean and build. Build failed because these modules are still present. I mean, the XML classes are still present in Java 9, but they're not enabled by default. We need to enable them with these add modules. And if we get rid of this illegal access, this tuning at opens, because from our code, we are taking a deep reflection into the string, right? So let's remove this column as well, and let's run it. Now it should, now it should crash with something different. See, illegal reflective access made, and this is this debug option, this mother-in-law, so it will tell you where exactly it happened. So we are performing an illegal access to the value of this string in here. This is what it's telling us. So to get rid of this warning, like I know what I'm doing, we need to pimp our Maven or build or whatever, or Gradle build, or ideally we should get rid of this illegal access, okay? Or deep reflection, broadly speaking. Okay, so let's switch to Java 11. And again, the output is more or less the same. String still has bytes inside. So what has changed? See, I needed to add these implementations. Like it would have dependencies in your POM file as well, because there is no such module since Java 11 to enable to have all these Javax dot something classes, packages, methods, and so on and so on. So you simply need to check what to add to have this and to keep this running. Just instead of having this in Java, kind of embedded or itself, we need to add an external dependency. And do we have any changes in here? No, I don't think so. So there's another thing I'd like to show you. Is just this is like this is another application. What it does is also like Not very important. I have just two threads, a consumer and producer thread. And the thing is that the producer produces much faster than the consumer. See, the producer sleeps only 50 milliseconds and the consumer sleeps 100 milliseconds. So what should we expect in this case? Any guesses? I still have some jellies. No volunteers. Of course, we'll get out of memory exception. And but let's say we don't know what this code is doing. We might not even have access to this code. It might be just an external, like a library from an external provider, vendor, so we don't have the code to trace it or to profile it elsewhere. So how we can do that? We can do it like this. Let me show you the Gradle's build. As you can see, here I'm using this Java Unified Logging. So I'm telling Java Unified Logging I want to log everything GC related in debug in such a file. By the way, don't log to TMP, it's just for the demo. And this is the format of the log entry. If after I run this application, I get such a log. As you can see, it's quite huge. Let me decrease the font size. Yeah. And you can see everything that happened with GC for this application. And it's pretty long because it's debug. But you can see everything that happened. I mean, every GC cycle and so on and so on. OK, I'll stop scrolling. There's another option to see what happened. And this is what I really, guys, recommend it to you. There's another session on Java Flight Recorder. And if you're not using Java Flight Recorder, I think you should, because of these options. Sorry, not here, not here. Oh, here. I am starting Flight Recorder. I'm recording. It's like in Polish, it's czarna skrzynka. It's like a flight recorder in the aeroplane, right? So we're recording how the plane is like going through the air and so on. So how it behaves in the production, since takeoff till landing. So, and this is what we have in Java 9, for sure in Java 11 with OpenJDK as well. So we can record it to disk, we can dump it on exit, and again. I'm not going to run it here. See, I'm calling this application with some what is your password baby arguments. This might be important. And I have just this file open for analysis. And this is how it looks in Java Mission Control. I mean, you create this recording using Java Flight Recorder, and then you can open it in Java Mission Control. And as you can see, it's already saying us that in this automated analysis results, that Java application, there's something wrong with the threads allocating, that the producer is creating most of the objects, that the application holds way too many times because of the GC, that the free physical memory at that time was really low, and so on and so on. It's even so nice that it tells you that one of the parameters was password, and it looks suspiciously because you shouldn't provide passwords as parameters or as arguments to your application. It's even that good. And if you're interested what happened to this garbage collector, you see nice charts, what happened, when, how long did it take, sum of pauses, and so on and so on. You have this TLAP allocations, you have this exclamation mark warning for memory and live objects, as you can see. So it's really nice tool, especially for DevOps guys, to see what actually happened, how this application behaved in the production in easy, nice, and graphical way. I think it's a bit easier and nicer than analyzing or grabbing this log file. Okay? Two more things. Of course, there's JShell. It might be nice and easy and handy for you, because what we used to do, we used to write a lot of this hello world, like a public static void main method and so on, just to test anything, or we are creating dummy JUnit tests, okay? Now we don't have to do that with JShell, so the file looks more or less like this. See, this is just a script. I'm using the var. Here, so I don't need to write string 1 and so on. It's much faster. See, it's like just the content except this exit. It's just like the content of this public static void main method. And using JShell, I can, of course, run it in interactive mode, or I can feed this file to JShell to execute it. See, so I don't need to explicitly compile the code. And what's even maybe nicer, I think Java finally allows you to create JavaScript. Really. Let's take a look at this file. Does it look similar? Do you know it? This? Okay. Notice this line here. It's called shebang. So if you have bash scripts or Perl scripts, you write here that this should be run as bash or whatever, right? Or as shell. And we can now say that this should be run as Java. Okay, source 11, and see what it will do. Let me find the core. Yeah, see, I'm not doing any Java-C. I'm not doing any Java. I'm just calling this script because it's executable, and it works. Of course, you should have noticed that now Java supports Unicode much better. I mean, all these fancy emojis. And this file should be executable. And this is also an illustration that since Java 10, as far as I remember, Java is aware of these constraints by containers and so on, so we can get in your Docker images and so on better information, how many cores you have, what's the free memory, what's the limit, and so on and so forth. So as you can see, there's a lot of new stuff really worth the migration. If you like to have a better migration, do you know this pet shop application from Spring, with Spring? Do you know it? Yeah, so there was one guy who created this nice blog post migrating this application to Java 11. You can read it. It has Maven. If you'd like this talk, you can have training with me. I have training about migrating to Java 11, all the good new stuff in Java versions 9, 10, 11, and even 12. There will be one if you'd like to extend your Confitura. During this Saturday, I have a training on Jigsaw on Sunday, and there should be something in Tree City Jack in August, as far as I remember, in case you live in Pomorze or somewhere in there. And remember, guys, always, and for everyone, for every speaker, not only during this conference, but every conference, please provide your feedback, because we value your feedback. Using it, we can improve our skills, our presentations, and using this feedback, next time you'll get better speakers and better presentations. If you're shy, no worries. You can even handle a paper form, as I was once given such a form. Don't worry, I even accept such a feedback. Thank you very much for attending this talk. I hope the migration will be easy for you. And this is the link to slides and the code, and we have 2 more minutes for questions if you have any. Maybe I should move aside. Questions, comments? Shout it out. So the question is, should we not use the reflection at all? There are 2 concepts called deep reflection and shallow reflection. So more or less, shallow reflection is kind of a dynamic loading. So as you could have seen Mario explaining that in a previous session, it won't work with Gradle, for example, or not always work. And this is more or less pretty okay. It's kind of dynamic and such stuff. Deep reflection, however, is kind of like, Java is supposed to be object-oriented paradigm, right? So with this deep reflection, we're effectively destroying this paradigm. That's why, in my private opinion, it's just my opinion, Java is trying to discourage us from this. Okay, so it was never a good idea, in my opinion. Sometimes it was necessary by some tools, but now they're making it like more difficult to achieve, or more verbatim, let me put it that way, if you do it. Half a minute for another question. Oh, there's one.
What about dependency? Like, if we have a project with dependencies that is built with Java 8, should we use a new one, or is it possible to use the old one with
if I understand the question, should we have a new build, like new jar? Yeah. Yeah. So the question is more or less, if I read it correctly, if I'm already using some external dependencies and these are compiled jars, can I use them or should I recompile them? You can use them as long as they are just normal standard edition applications, which should work. Okay. So if they're not using any removed API, they should work. Okay, we're out of the time. Thank you very much for attending this talk. Thanks.